In this example, there are 7 pieces of information given. We'll represent each by a letter, starting with A. A represents the station location. So A here is KOKC. This is a 4-letter International Civil Aviation Organization code where the weather was observed. Every airport in the world has one of these codes. Airports in the continental U.S. begin with K, while those in Alaska and Hawaii begin with P. Airports in Canada begin with C, and those in Mexico begin with M. In the Bay Area, San Jose International Airport is represented as KSJC. Oakland International Airport is represented as KOAK, and San Francisco International Airport is KSFO. So for this particular METAR, the airport at which the weather observation is taken was KOKC, Oklahoma City International Airport. Okay. The next piece of information, given by the letter B, it's a string that gives information on when the observation was taken. And it is composed of 6 numbers followed by the letter Z. The first 2 numbers represent the calendar day of the month. Hence, the 20, in this case, means that this METAR was taken on the 20th day of the month. Now, it happens that this particular METAR was taken in January, but the METAR doesn't explicitly tell us that. So keep that in mind. The METAR gives you the calendar day of the month, but not the actual month. The next 4 numbers give the UTC time that the observation was taken at. UTC is also sometimes called GMT, which stands for Greenwich Mean Time. It's the current 24-hour time in Greenwich, England. Since there are weather observations taken every hour at numerous countries all across the world, and this data is exchanged between these countries, there needs to be a set time that nations can agree on to use. Because if each country uses one or more of their own time zones, things could get confusing, right? So UTC is a set time zone that all the nations of the world agree on when they exchange weather information with each other. And this weather information obviously is, useful for analysis and forecasting. Since Greenwich, England is east of the U.S., their time is several hours ahead of that in the States. During standard time, UTC is 8 hours ahead of Pacific time zone, 7 hours ahead of the Mountain time zone, 6 hours ahead of the Central time zone, and 5 hours ahead of the Eastern time zone. But during daylight savings time, when we shift our clocks an hour forward, UTC is 7 hours ahead of Pacific time zone, 6 hours ahead of the Mountain time zone, 5 hours ahead of the Central time zone, and 4 hours ahead of the Eastern time zone. Does this make sense? Also notice that AM and PM information is not given. Again, we're dealing with 24-hour time. If the 4-digit number is between 000 and 0059, then that means the time in Greenwich, England is between 12 and 12:59 a.m. If the 4-digit number is between 0100 and 1159, the time is between 1 a.m. and 11:59 a.m. So you just basically take the number and then add an AM to it when it's between 0100 and 1159. Then when you get to 1200 to 1259, that means the current time is between 12 p.m. and 12:59 p.m. Once the 4-digit number exceeds 1300, then you need to subtract 1200 to get the local time in Greenwich, England, which is PM. So this, for example, 1500 24-hour time would be 1500 minus 1200, or 300 PM. So 3 PM UTC. 2359 represents 11:59 PM. And then the next time will be 000 for 12 a.m. midnight the next day. In this particular example, the time is 0552, which is 5:52 a.m. in Greenwich, England. Now remember, this observation was taken in Oklahoma City. The part A of this code tells us that. And Oklahoma City is located in the central time zone of the U.S. And also, as we said earlier, this particular METAR was taken for January, and that is when Oklahoma City was observing Central Standard Time. So to get the local time in Oklahoma City, you need to subtract 6 hours from the time in Greenwich, England. So 6 hours before 5:52 a.m. would be 11:52 p.m. the previous day. So remember how this METAR told us that the calendar day of the month was the 20th? Well, that's the 20th in Greenwich, England. So this particular weather observation was taken during the early morning hours on the 20th in Greenwich, England, but that was at 11:52 p.m. on the 19th during the late evening hours in Oklahoma City. Hopefully this makes sense. Don't worry, because we will look at more examples of METARs and you'll get more practice of converting from UTC to local time if you need.